But today it's in the role of a solar system ambassador. Neil and I are part of a JPL volunteer program that does STEM talks in the community. But I got the idea for this topic going through the Space Gallery on what must have been my 5th or 6th practice check ride. Thank you, Chuck. And noticed how it's very manned exploration centric. I started digging into what's been going on in the years since and what we project the next decade will be, and came up in December with a notice that hardly received publicity at all. 2 lunar landers, commercial lunar landers, are going to be sent to the moon on the same rocket. Commercial rocket, 2 commercial landers, and almost no publicity. It's just not that big a deal anymore. So what I wanted to do is get my presentation. I may have to do it from here. There we go. To talk about the missions, and I chose the 10-year period kind of arbitrarily. We'll talk about who's sending them, because the field is a lot wider now, not just commercially. What they're carrying and what they're going to do. Okay, first you need a functional definition of a robot. I like this story. So far as I've been able to find out it's true. Engineering design class about a decade or more ago put out a challenge to students saying design a robot that will wash dishes. And they got like 15 different designs. All of them kind of look like this. This was the answer. It does everything. What you're looking for in a robot, and this is the definition I'm using for the presentation, is it interacts with the environment. It doesn't just sit and observe, so that kind of puts out a lot of pure space probes. And it has the capability to make changes to that environment. And size is not an issue anymore either. Now, some can be small and very powerful, and that's what I think you're going to see here this morning. This is a list of all the probes right now in space that are actively sending data back. These are all active missions. Go back to 79, Voyager 1, Voyager 2. The next decade is going to look more like this. There'll be some carryovers. I mean, the space world doesn't start in 2025. Venus is real active. There's 5 international flights making a new rush to a planet we haven't studied in a while, but they are largely probes, so I'm going to ignore them and concentrate on an addition, which is the Earth. Okay, I'm going to start there and move out into the solar system. And this is the problem, this is why we're dealing with robotics here on Earth. Space junk is starting to get a lot of publicity. It always has had publicity within the science community. But now the commercial world is starting to take notice too. In 2014, we had 200 objects a year added to objects in orbit. By 2024, that's more than order of, what is it? 12, factor of 12. There are more than 25,000 tracks of objects in space that are 4 inches or more. They presume that the number that's a ½ inch or more, number is 670,000. And that's big enough to puncture the ISS. And there, again, an extrapolation, 170 million that are down in the tiny weeds. The reason that's such a big deal is because it's growing, and it's growing exponentially. This is something I got off last month's Scientific American. Space junk, not active probes, space junk. Cumulative objects in orbit. Now the yellow part is stuff that's just burning up already on its own. But you can see that the number is still, let's see if I can get the pointer. There we go, just doesn't show on the screen. From 1960 up, you can see that it's still exponentially increasing. And I've put the line there at 2020 just to show you what 5 years will do to the number. The Problem is the Kessler syndrome. It's something I hadn't heard of until just a few years ago, but I'm seeing it more, at least in NASA literature. And it's concerned to the commercial world too. That's where you reach a threshold point where there's so many things floating around, so many high energy objects, that you can start a cascade of collisions that can make low Earth orbit essentially uninhabitable or unusable. So where one particle hits another, breaks it into 2 pieces, now you've got 3 pieces, they each hit a piece, now you've got 9 pieces, something like that. Some astronomers think it's already happened. It looks dramatic, it looks sudden, but it doesn't actually take place that way. It's a lot slower. But once it starts, it's considered almost unstoppable, unless you take some action to try to help. This isn't much, but it's a start. And it's something that's within the past decade, active debris removal from orbit. There's 2 companies here that are working for the UK Space Agency in a competition. They're going to down select here in a few months. These guys have the advantage of actually having demonstrated an end-of-life service solution to getting satellites that don't work anymore deorbited. They call it end-of-life service. It's really a magnetic plate that attaches to a magnetic plate of a defunct satellite that presumes you designed it with a plate to begin with. So it's not much more than a demonstration, but they've done it in space. Astroscale, interesting company. It's Japanese startup. The guy who started it used to be part of JAXA, the Japanese Space Agency, and he was so disgusted about the lack of thinking on this topic that he went out and formed his own company. And that's how this started. They also have active debris removal, which means they'll hook up to a satellite of any kind and deorbit it. Don't have to have that magnetic plate, but they haven't done it yet. And then their other solution is life extension. Take a satellite, I'm thinking of Skylab, it's reaching back, I know. A satellite that's basically still functioning, but it's running out of fuel, it's running out of power, and boost it into an orbit where it can continue, even if it means providing it with a fuel package too. ClearSpace is their competitor. This is a Swiss startup. What they're coming up with looks a lot more like a robot. But again, the idea is to grab onto it, they propose it in a demonstration in 2026, and deorbit. This is Northrop Grumman. This is backed up by Office of Naval Research and DARPA. And they've tested it, but I haven't heard anything since the tests. This is designed to hook onto a satellite again, mission extension, boost it into a higher orbit. They also are expanding into 2 other services, which is a mission robotic pod. You attach it to a satellite and it's a power package. It's like the service modules for the Gemini and Apollo missions downstairs. And mission robotic vehicles, which I haven't seen a model of, which will actually hook on, take it apart, repair it, remove it if necessary. It's pretty comprehensive. The general state of the art right now is destructive reentry. Put it back into the atmosphere and let it burn up. Life extension is a fairly new one, so they're still working on that, and they haven't got much more than demonstrations. This is starting to make the rounds too. We recycle $500 desktop computers for their electric components, and yet every time a satellite goes up with state-of-the-art electronic material, which presents an environmental issue when it burns up, we just let it destroy itself. The thought here is to develop a range of satellites that can be serviced this way, like the Hubble. They can take boxes out and put boxes in. I haven't seen much progress there, but the fact that industry is coming forth to try to offer solutions here, you're probably going to see that on satellites that are launched sometime this decade, but anything now is probably just too complicated to open up and have anything to do with it. Okay, that's the Earth. We're trying to solve the space junk problem, but we're solving it with various degrees of new robotics. I'm going to go to the moon now, and this is the big one. This is the one with a long list of new missions. There are 5 successful missions that have reached the moon since 2013. 3 are Chinese. They're all defunct, by the way. They all served their mission life. 1 from India, 1 from Japan. One of the Chinese missions is still active. I'll talk about that in a second. No, 12 plus. I say 12 plus because we don't know what new contracts are going, and there's one iffy one, even under the current contract. Okay, this is Hakuto R. I've come up with at least a dozen different definitions of what Hakuto means in Japanese. I don't know which one to pick for this. But this is run by iSpace. This is a Japanese company doing its own commercial landings, its own lunar exploration. I separate it out from the others because it's a real aggressive program, and they're kind of doing it on their own. They're going to land up here in Mare Frigoris. It's this long stretch toward the north. They have a rover, Tenacious. It's 12 inches high, it only weighs 11 pounds. It's a regolith digger. You'll find this is common in most of the missions. They have small rovers. You see the panels on the side of the launcher in this kind of sail. They're all using solar power, which makes total sense. It's small, but it's there to detect and process lunar surface material, regolith. They're looking at it as a potential source of fuel. They're also looking at it as a building material. Now, that's a pretty small package just to do that kind of digging, but they claim it's going to have pretty comprehensive analysis within itself. Also, there's a food production experiment going on in the lander. Details I have shows it basically growing plants. There's nothing else that could realistically produce there. But if the idea is sustainable development, then a lot of the missions, including the ones I'll talk about here next, are digging into the surface to find out its properties and what it can be used for, and coming up with techniques that can keep a human space base alive, either food or energy or water. I called this out separately too for another reason. There are, what did I count, 9, 6, 7, at least 8 more missions. So they have a program. This is you're going to see the next one in 2026, but you're going to see more throughout the decade. This is a pretty ambitious program. Like I say, it's kind of self-contained by the Japanese, although this is one of the landers that was sent up in the SpaceX rocket on January 15th, one of the 2. Okay, this is the US program, this is the NASA program, commercial lunar payload services. Try to do essentially the same thing I just described in advance of Artemis. It's a turnkey commercial mission. They will give you money, but you're responsible for everything. Find the launcher rocket, get to the moon, do your act. NASA's hands are free. It was established in 2018 when NASA's own Lunar Explorer program got canceled. It focuses, like most of these missions, on the south lunar pole. The reason is they can land close enough to day-night conditions that they don't have to travel back and forth, and there is water confirmed on the south pole in the craters. Don't have the temperature, but I'll get that to you in a second. This is a 2020 report from NASA, and it basically outlines and codifies all those sustainable things. They want to build a lunar base that lasts, that provides a jumping off point for Mars missions, that does all the science and technology needed to make that happen. And they want to emphasize in situ. This is true for Moon and Mars. If you can build from local materials, extract local water, then that's what you have to do to make something sustainable. Artemis 2 is going to be an orbital trip around the moon. Artemis 3 is the first planned landing. These are each 2 years behind schedule. So as of now, that's the plan. So there's 4 missions here under current contract, and they expect bigger payload missions after 2025. And I say that because the information now is current as of Saturday. If anybody's read the news yesterday or today, NASA's totally up with DOGE, just like every other agency, and the advisory committee meetings have all been canceled. So I'm giving you the best information. The wheels are turning, and they're turning in this direction. This is the first of the 4, Mission 1 Blue Ghost. Some of you might have seen that taken on its way in. It's done by Firefly. It's only a 60-day mission. It's a regolith mission. Let's just find it and analyze it. This is the second of the 2 that went up on the Falcon 9 rocket in January. This is Intuitive Machines, so the mission number is IM to distinguish it from others that are sequential as well. It's only about 7 feet high. Looks bigger than it really is. It's landing down in Shackleton Crater, and you'll see a lot of these other missions that do the same thing because that's where the water is. I was still looking for the temperature. I'm going to have to wait till I see the numbers. It's going to drill for water ice. These are 2 commercial entries that I was impressed by. If you're going to build a sustainable base on the moon, you need data services that don't involve sending everything to and from the Earth, and you need a communication system that isn't just line of sight telephones. So Nokia has graciously and probably profitably offered to set up a system that's 4G LTE quality cell service, and Lone Star Holdings is developing their data center to make it a repository. It won't be standalone, but it's a start demonstrator. Also, they've added a micro Nova hopper, part of the Nova suite of equipment. And that's what it looks like. 22-pound payload. It weighs like, more like 10. This is what I was looking for in the 1.6-mile range. The surface temperature is 250 degrees in the day, Fahrenheit, minus 208 at night on the surface of the moon, big range. It goes to minus 370 in the craters. So just operating in that temperature, does anybody know what Kelvin, 0 Kelvin is? Yeah. I mean, I don't know the number, but this seems to approach that. So they're relying on this to hop on over and check it out. And I said, they're using a lot of solar power. It's dark in the crater. So this is a demonstrator to see just what we can accomplish by trying to extract water in the crater, by seeing if we can get a platform that can survive those conditions. Blue Moon. This is the one when I put the 12+ missions. We're not sure about this, but it's just too big not to go. It was supposed to go in the summer of 2025. This is Jeff Bezos' Blue Origin company. It's a huge, oh, there it is. I put this down here now. It's a 3-ton cargo hull. It's 3 times as big as anything else, almost 4 times as big as you've seen. It's not going to go in Falcon 9 rocket into orbit. It needs its own rocket. And Blue Origin has it, the new Glenn. It did launch successfully on January 16th. Cool, went into orbit, but it's way behind schedule. So it's doubtful. This isn't currently not under contract under this program, but hopefully will be. We don't know when it's going to launch, but it's just too big a capability to ignore. So somewhere along the line, they will fit that in. This is Griffin 1 by Astrobotic, Noble A crater. There's Noble A, Shackleton, and one other down by the South Pole. Everybody's going to the South Pole, including the Chinese program, as you'll see. This is a little misleading for the size. This is about 7 feet. It's carrying ramps to offload a lander, and that lander is going to be a payload. Originally, it was supposed to be Viper, which is a volatiles explorer looking for water and other materials that NASA had built. It's way over budget. Finally pulled the plug on it just a couple months ago, I think now. And that was going to be canceled. Well, Astrobotic immediately went over to Flip. You can see the big solar panel there. This weighs in at about 1,000 pounds, and it can carry, what is it, 60 to 100 pounds of material. Not every platform is an Explorer. Sometimes you just need a pickup truck to get things done where you're going, and that's what this is supposed to be. That's going to go September 25, but in the meantime, Viper came back to life. They're putting out commercial requests for proposal to see, can you salvage this? This is what NASA's produced. Can you finish it and make it flyable? So we'll probably be hearing from Viper in the future too. And the last one of the intuitive machines. This has a couple of good payloads coming up in the fall. Lunar Outpost has done the mobile autonomous prospecting platform. It's digging up regolith and storing it. Now, it says it has a 22-pound payload. It says it's going to make that for sale. This is the first time I've ever heard of this. But basically, you're picking up lunar material, and if anybody wants to come get it, they will sell it to you. Because right now, pretty much all of our lunar-based simulations here on Earth, all our lab studies are based on analogs, stuff that looks like lunar or Martian regolith. They're all planning at least 2 more missions, with a bigger one that does 66 pounds, or 33 pounds, and then a third one that'll lift 550. So they got ambitious plans. Together with this mission is also the Cooperative Autonomous Distribution Robotic Exploration. I'm glad I put that up because I can't remember these names for the life of me. Cadre. There's only 2 here, but what this is are 3 NASA robots that will do ground-penetrating radar independent of anybody else. They are all autonomous. They will coordinate with each other like a hive, like a robot swarm that we hear about in DOD. But they're going to create that 3D map completely on their own. And that's a pretty big step for autonomy, even with just a single mission, like ground mapping. This is a summary of what I've just shown you, and they're all different aspects, so it's probably not very accurate, but you get an idea of how big these are compared to Blue Moon and why they need Blue Moon, and against something else that we recognize, like the Apollo lander. I said this is what's contracted now. It's supposed to be another round of contracts for more ambitious missions next year. Hope it happens, but the program, if anything, will get more ambitious. This is a Starship Lunar Cargo mission. Expected launch 2026. I'm not sure how firm SpaceX is on this. This will be the first time that Starship has landed a rocket on the moon. Right now they launch you into orbit and it's like the lunar module. You go the rest of the way and land. This thing is going to land on its own, and it's got to because it's carrying some pretty huge cargo over there. And this is the first payload. It's called Flex. See if I got something on Flex. Nope, guess not. It's about 8 feet by 8 feet. It's a personal transportation system, but like I say, sometimes you just need a remote hauler. I put that in the category of, I think this is Army, they used to call them mules, where the ground infantry just uses this to haul a lot of stuff while they're on the move. So that's 1,100 pounds. That'll be the biggest payload ever delivered in a single go for new lunar missions. This is barely a robot since it's under Earth control, about the size of a suitcase, 45 pounds. Australia is really proud of this. They call it the Rover, after a national naming competition. And again, like a lot of the payloads you see here, digging for regolith, but it's going to be their first, I think it's, their first rover. This is a tight program and one to really watch. So far, the Chinese have done an outstanding job in orbit and for their lunar program. They had a quote in 2019 from the head of their space agency. They want to build a scientific research station on the lunar South Pole within the next 10 years. And that was said in 2019. It's, again, they're going to the South Pole too, for the same reasons we and everyone else are. There's water there. This is just a research station, but they say they're expecting crewed landings by 2030. And when we're looking at 2017, and that may slide, this is pretty competitive. And I give them credit for being able to pull off things like this. These were their targets for 3 different classes of lunar mission, and they've met every single one of them. Okay, Chang'e 4 actually launched in 2018. It was the first spacecraft to land on the far side of the moon. It's close to the South Pole, but it was out of radio communication from the Earth. Remember, that was the big fear with Apollo 8. You go behind the moon, you're out of touch. It had the first spacecraft to land successfully there, had the first rover. And here's the cool thing, they're still functioning. 7 years under lunar conditions, and they're still, keeps on ticking. The new ones are these. Again, Shackleton, Orbiter Lander rover on Chang'e 7. And they're going to have a mini hopper too. Rocket propulsion makes sense here in such light gravity. There's another technique I'll show toward the end, but this works just fine. And Chang'e 8, again to Shackleton, is going to have a 220-pound rover. That's the biggest one except for the one payload I showed you for Flex. This time they're going to do a mini enclosed ecosystem. They didn't say food production, it's just a living experiment. And they're looking at 3D printing, most likely with lunar regolith, trying to build structures and tools with the materials that are already there. This is the last one. I don't know much about it. Lander and rover cooperation between India and Japan in 2028. Again, regolith. So there's a lot of overlap here in the missions. But you almost can't have too much data for a place we haven't been to in over 50 years. Okay, I'm going to planetary programs. I put the line there because that's about as far out as our plans take us. First is Mars, and this is a Japanese mission. And it's, doesn't say which rocket they're using to launch it, 2026. They're going to send this out to do a sample return of Phobos. There's 2 moons of Mars. Phobos is the big one. They don't know, the mystery is we don't know where they came from. Were they pieces of Mars that got blown off on an impact, or were they asteroids that got caught? So the whole physics there, the whole history of geology there isn't pinned down. So that's what the Japanese are doing. And this takes us back to the US program. They pretty much confirmed that there was, and most likely is, accessible water on Mars. The pictures they've taken ever since Curiosity show the marks of dried up water, ripples in the sand like we see out here in the bay, and blueberries, which only occur on Earth under rapidly running water. That's why Perseverance went to the Jezero crater, because they thought this is what they were going to find. They had the most likely chance of finding. Methane was discovered about 5-6 years ago. It's basically, what cows produce, the gas. It can be produced biologically, not 100%, but they're excited about the chances for life there. And we've invested in 2 rovers for that reason. Curiosity is still active. Still zaps rocks and finds the gases that are emitted and what they might mean. They wanted to find out if it was possible. The mission for Perseverance is a taller order. 2021, that date's important here in a second. They're looking to see if there really was life, or is, but that's always fingers crossed. And this is how they want to do it. You've probably heard of the Mars sample return. It's really exciting. They're going to go around with Perseverance. It's going to pick up samples in test tubes. And I know it looks like a series of Amazon delivery photos, but it shows the context where they gathered each sample. Then they're going to put, Perseverance is going to put them into a big canister, and that thing is going to be picked up by another mission. That always struck me as brazen, but there's a million engineering reasons why you can't put this all into one. This part of the collection is largely over, if it isn't over as we speak. So we're just waiting to how we get it. Now, the original plan had two things. You're going to go there in an orbiter, a lander was going to come down. There's no robot here. They're probably dependent on Perseverance to bring it over to wherever the lander is, pack it in, and go back. The original dates were to launch. 2 years later, they were going to go into orbit. 2029, this was going to launch and go into orbit, transfer, and then the whole thing was going to head back to Earth. It's way over budget, seriously over budget, to the point they were looking at canceling it. They probably, well, it's too important not to do. They slowed it down in 2023 when they realized just how much trouble they were in. They delayed a decision on the equipment until 2026. To my knowledge, there is no equipment yet. These are all artists drawing for a reason. But they did go out for commercial proposals, and they've narrowed them down this year to 2 options. So they'll probably make a decision next year, however long it takes to build the equipment and then launch and then get back. The reason is the orbits of Mars and Earth are such that there's a every 2 years there's a window of a short trip. And then it gets expensive and ugly and time consuming. So you see a bunch of missions go out and then you don't hear anything, and 2 years later there's another bunch of missions. That's the way it works. This is a bittersweet mission. ExoMars is a European Space Agency. It's a rover. Unfortunately, it's sitting on a Russian lander and was supposed to be delivered by a Russian rocket. Just not happening. A lot of stuff got canceled with the Ukraine invasion. But they found another way to pull this off within ESA with NASA's cooperation. So they still want to launch it in 2028. It's important for this reason. Perseverance did a wide, shallow search. This is designed to do deep searches down to about 15 meters, ground penetrating, I don't know what other sensors they have. But they were a great complement, and half of that complement is going to have to wait for this. Asteroids are going to be quick. This isn't the asteroid defense. I know you heard there's a couple of them that are going to wipe us out in a few years. They're looking at them. Asteroid defense is a big issue, but this is just why we go out and send a robot to develop and bring back a sample. It's because it's pristine. This was Bennu from OSIRIS-REx. This is what they found from it. It's not contaminated by the Earth. That's why you want to get an asteroid. You can get a lot of this stuff from meteorites, but if they've been sitting in the desert for 20, 30 years, it's tough to tease out what's different. But they've done this. They've done Hayabusa. Those are 2 asteroid sample sets, and they're all showing these kinds of results, which means all the ingredients for life are in the solar system from effectively the beginning. OSIRIS-REx had, I put this up here because it had this kind of a recover mechanism. It just stamped, it didn't land, it stamped into the surface, blew a ballistic charge, and then it collected all the stuff that flew up. That's only one of 2 ways of doing it. They got the sample back here in 2023, but they found out, hey, it's got a quarter of its fuel remaining. So they sent it out on another mission, and that's where it is now, on its way to another asteroid. This is the Germain mission here. It's Chinese, May 2025. This is pretty ambitious. It's going to rendezvous with Kamo-Oalewa. I dare say no one's going to correct me on that pronunciation. Which used to be a piece of, they think it used to be a piece of the moon. It's going to go out there. It's going to gather a sample, which makes it a robot. It's going to bring it back, spit it out to Earth reentry, and then it's going to swing around and head on out to a comet. It's a pretty ambitious mission. The reason I bring that up is it's going to do the stamp like OSIRIS-REx did. It's also going to take like grappling hooks and hook it into the asteroid, which no one's ever tried before, to gather another sample. Okay, this is a great slide for STEM audiences. Most people don't see this when you ask them, where's all the water? Most of Earth's water is on the surface. That's it compared to the volume. That's what all these show. We're a desert planet compared to some of the moons out there. And NASA is going to send something to Europa and to Titan, which I'll spend the most time on. The ESA is sending out a mission that's going to hit 3 moons. These are orbiters, these aren't landers, which means they're technically not robots. But the science question they're asking is so important I wanted to use it anyway. Why Europa? And if you see the cracks here, if it looks anything like lake ice in the winter, there's a reason for that. These are ice moons. And they're cracking because the temperature changes and they freeze up and they kind of semi-thaw. In 2015, Cassini went by Europa and it found geysers coming out of the surface. Something had to drive it. Something had to heat that water underneath hard enough to work up between 5 and 20 kilometers of ice. Now, we've already done the research on hydrothermal vents here on Earth. Hot water isn't a barrier to life. Lack of sun isn't a barrier to life. Lack of oxygen, most recently, isn't a barrier to life. What they're seeing with what Cassini could sense was there's a liquid ocean here, and it's a hot one, and it's combining with carbon and other minerals, and with hot enough water to make it all the way to the surface. The problem is Cassini didn't have the sensors to definitively say what was there. One NASA astronomer I talked to said, these things could be shooting out alien shrimp. And we never know it because we haven't got the sensors to pick it up. This is why it got heated. These are elliptical orbits that we're talking about. When a planet, or a moon gets close to its central body, the gravity of Jupiter, in this case, stretches it out like a football. Then it releases it as it goes around and gets far enough away. This happens to our moon. That's why we have tides. It affects us, affects the moon. But the moon is big enough compared to the size of the Earth, we don't notice it. Here, everything is a fraction of the size of Jupiter. Our moon orbits every 28 days. This orbits every 3.5, so it's getting that squeezing, and that's where the heat's coming from. So the European Space Agency is going to go check that, and other ice moons. Very complicated mission. It's on its way. Ganymede, Callisto, and Europa. And we are sending the Europa Clipper, or have sent the Europa Clipper, to pick up what's in those vents. It's fundamental for a couple reasons. First of all, these ice moons, how widespread are these ice moons and their liquid oceans underneath in the solar system? And second of all, if they don't require the sun for heating, for getting this kind of heat and maintaining a liquid ocean, the habitable zone kind of goes away. We look for life in a habitable zone of the solar system, where liquid water on the surface could be present. This means you don't need any of that. There could be life out here in Jupiter and Saturn's moons. And once you get away from that habitable zone, you open up the realm for life dramatically. There's a better set of geysers on Enceladus. I was kind of surprised that we didn't send the mission there. Turns out that when the mission was planned, they only had a certain kind of rocket. It was okay for Europa, but it wouldn't do a good job with Enceladus. Most recently, it's a couple of weeks ago, they think the same thing's going on in Ariel, which is a moon of Uranus. So I could move my line out there if we had a mission going that far. That's why I say it's an orbiter, it's not a robot, but the question it's asking is so fundamental, I think it deserves inclusion here. Okay, Titan, moon of Saturn. The same Cassini orbiter dropped a lander in 2005. It got some great photos as it came down. The thing about Titan is that it's the only moon with surface liquid and weather. These are lakes full of methane. One astronomer said it's like Lake Michigan full of paint thinner. The methane is at a triple point, which I've never understood from chemistry, but it evaporates into the air and rains methane down. It has ice volcanoes. The water on the surface is ice that comes from further down into the planet. So it's got a lot of organics. This is ingenuity. We saw that from for years now from Perseverance mission. It was scheduled for 4 missions. It did 72. It was a booming success. What's lesser known, though, is the air pressure, atmospheric pressure on Mars is like 0.08% Earth pressure. So this thing was flying in the Earth equivalent altitude of over 140,000 feet. Successful system. Atmosphere on Titan is 1.5 times that of the Earth. Mars' carbon dioxide, nitrogen is for Titan. But it's a thick, heavy atmosphere, and instead of, I think Mars is a third Earth gravity, it's only 14% on Titan. That makes it perfect for another flyer, a behemoth flyer. Planned 2028 launch. The hardware's already being built on this one. That's about how big it is. It's 900 pounds. There's Perseverance and Curiosity. They're all using, it's too far away for solar, so they're all using a radioisotope generator for power. I say that because people see this picture and they think that's the head up there at the other end. It's not. 12-year mission, can go 13,000 feet at about 30 miles an hour. Here's why this is important. Mars, one-way radio frequency, depending on orbits, is 5 to 20 minutes, one way. And we do that with Ingenuity and Perseverance and Curiosity. Titan, it's 1.5 hours, give or take. You're not going to control this, you're not going to update it, so it needs a considerable amount of autonomy. Another issue is it's sending data straight to Earth. There's no, unlike Mars, no orbiting satellite that you can send your data to, have it amplified, augmented, and then it's shot off to Earth. It has to do it all by itself. So this thing has to function on its own for great periods of time. The idea is to land, do some samples, go to another location, take some more samples. And those are the missions as they stand now. I'll just do it quick because of time. These are vehicles that are already undergoing engineering tests here on Earth, looking for lunar and Martian tunnels, for roving around under an ice sheet, in the case of ice moons, if they can ever drill down that far, or floating on Titan's lakes. I mentioned how rockets would work in light gravity. There's also a system using inertia wheels that we use to guide and stabilize satellites. But if you can control their speeds, you get forces that can push it into desired directions. So if you're too far away for solar, there's still a way to get around on small worlds. This is the last one. You're welcome. But there's talk on both the moon and Mars of building habitats made out of regolith or ice, 2 raw materials that you could 3D print. And there have been engineering studies to show you can do that. I'm making a slightly different point here. This is the automated, reconfigurable, mission-adaptive digital assembly systems, Armadas. This is a robot system designed for this. What they do is they tell the robot, and this is the significant part, they tell the robot this is what we want the final design to be. They don't tell it how to build. It figures it out on its own. So you've got a level of intelligence already being experimented with here on Earth, already being tried on future launches. And this is kind of the conclusion I was looking for as I try to put the Space Gallery into context. This was a TV series years ago about Mars, setting up a complete society. I enjoyed it. It took me a while to figure out it was being sponsored by SpaceX. But that's the Martian model, and it's a human model. It may look something more like this in the future. If you get robots that are that capable, that independent, and of course the technology will get better. This is a NASA graphic, 2004. They said, why are we putting people down on a planet and we could keep them in orbit, make things a lot, it's not free, but it's a lot cheaper and safer, and work a model like this. Carry that one more time and you may get rid of that entirely. Right now, all the way to Titan, year 2037, everything's robots. We're not going anywhere. That may be true on Mars. You've got to ask yourself the question, why are we putting people there if we can get the science, which we couldn't do back in the days of Apollo, if we can do the science another way. So it's about 1 minute to 11. I don't know how you want to.
Go ahead. Any questions?
Two questions. For the U.S., approximately as a percent of development, how much is NASA doing and how much are private companies doing?
Private companies, as you saw here, and as I did from my, NASA welcomes private companies. They take a lot of the risk, they're a lot more nimble, they're a lot more flexible. When I was here like 5 years ago, before I ever got involved here, I gave a STEM presentation on Artemis. And even as I was speaking, this looks a lot like warmed over Apollo. Some manifestation will probably occur, but that kind of thinking you don't have with private enterprise. Their services, they take the risk. So to answer your question, a lot of it's being cast off, and it's been talked about for years, saying NASA should be doing high-risk R&D. Let everybody else make the money, that's fine. We're not in the business of profit. So that's what I found out.
Okay, the second part is so many countries are working the same things. How much are they sharing information?
No.
My guess is not much. And again, it's like we talk about the Wright brothers and Glenn Curtis and how that worked out. Everybody there is a lot of money to be made here. One other said the first trillionaire is going to be somebody involved in this business. So, and the other thing I've seen is if you go to websites, there's a lot of cheerleading. This is great, this is wonderful, okay, but how? And that's kind of when they're keeping it close to the vest, and that's understandable. It's a new industry like a lot of others. AI.
Thank you.
Any other questions?
I don't understand. Why is there so much water in space? Where did it come from?
It came from the formation of the solar system. The only question is about the geophysics of the formation of the body, whether it's absorbed or whether it comes to the surface. I mean, I'm way out of my depth here, but I'm thinking of the Earth that had the tectonic plate maneuver. It still has tectonic plate geology, and a hot core has driven our water to the surface. Of course, once it's on the surface like Mars, it can be evaporated off into space. This just never happened on these icy moons. In fact, the more I think about it, the more logic that probably makes. They got frozen quickly.
Great, thanks. Anybody else?
Yeah, that's it. Thank you very much. Before we leave, I'd like to